Okay, so getting right at it, getting into a proof, which is a little t-table that you can only work on the left-hand side and the right-hand side separately without doing any algebra back and forth. And I'm introducing the proofs before we introduce the later trigonometric identities on our formula sheet, seen in formulas, because sometimes it's just a little bit more fun to get used to what's happening, and that's at least what I think. And then later we get into a proof with one of the double angle identities, and they do get a lot more difficult. So let's start off with the first question, 6.3, proofs, Pythag, reciprocal fractions, notes. So the first question says tan x cosecant cx is equal to secant x. And I'm going to draw a little capital T underneath the equal sign, and you can work on whichever side you want, whichever teacher tells you you cannot, doesn't understand. And there's a way to work backwards, but I digress. So tan x is sine x over cosine x. And cosecant is times 1 over sine x. And in red pen, I have a sign on the top and a sign on the bottom, so this simplifies to be 1 over cos x. And you can either work on the other side and say check mark, or work on the left-hand side and call it, excuse me, the right-hand side. Latin, QED, look it up, is a great way to say check mark. So we need to make, circling in red, the left-hand side equal to the right-hand side. And as I just like to do the first time, show that it's allowed. If you want to leave it here, and if you want to save the trees and save a line of graph paper and you just want to work on the right-hand side, do it and leave it and put a check mark or a QED and save a line of graph paper and go and ask every single one of the math teachers in your building if you're allowed to work on both sides. Not algebra to both sides, not bringing stuff back and forth, but not allowed to work on both sides separately. I bet you 9 out of 10 teachers will tell you you can work on both sides. So I'm going to divide the page in half, and I'm going to do another example off to the right. So we have cotan x. Notice I round my t's so they don't look like plus signs, and I round my x's so they don't look like plus signs, over cosecant x equals to cos x. Well, cos x on the right, that's pretty simple. I'm going to leave that there, and I'm going to work on this fraction. Well, before I even start, I'm going to think cotan is a fraction. Cosecant is a fraction. I'm going to have a complex fraction with 4 lines. I want to make a big over with enough room for at least 2 lines on the top and 2 lines on the bottom. I actually skipped a line just so it's really clear. So circling it in red on the top, cotan x is cos x over sine x. I hope you have your formula sheet and are glancing over and even checking my work, because I get stuff wrong all the time. Now, looking at the bottom of the fraction, on the top we have cosecant x, which is 1 over c first, flips with the s first, sine x. And now, I really don't want to work on, I shouldn't work on the right-hand side. I forgot my capital T or whatever. I don't want to work on the right-hand side. It says cos x, and that's what I'm shooting for, and I'm not going to, but I'm going to circle it. That's what the right-hand side says. But I want to save paper again, and you can see how I've done it properly in the notes. but I'm dividing fractions, so can't I just flip and multiply? I'm running into the other side a bit. Who cares? I know what I've done. I flipped and multiplied this fraction in brackets over here instead of wasting a whole bunch of extra paper. Now I can clearly see that I have a sign on the top, so I can cross them off, and I get cosine x, and I can say check mark. Look at the notes. I've highlighted them in different colors so you can see the flip and multiply more easily. But this is way more fun. And just because we accidentally ran into the right-hand side didn't mean that we were breaking the rules. We weren't doing algebra on both sides. We just ran over a line on our paper because we wanted to save the trees. Okay, so let's look at some more examples down below. So this next example, 1 plus tan squared x is equal to secant squared x. Well, that should look like one of your formulas, one of your Pythagorean identities at the top of your formula sheet. You should be looking at it right now going, wow, that's already a thing. Why do I have to prove it? For fun. We're mathematicians. We like to do things for fun. We like math. We want to do math all the time for fun. One thing I've noticed, my equation has run past half the page and it's bothering me a tiny little bit. So there, that's better. So I'm going to do this much faster now. I went really slowly in the first part of trig and substituting with sine and cosine. And we already talked about the ratios in the first section of this chapter and the second section. So let's go a little bit faster. So 1 to 1, I'm going to leave it, 1, plus tan x is sine x over cos x. So it's simply sine squared x over all over cos squared x. I forgot my t. I'm going to draw in my t. And notice I don't really like to waste too many lines. I did above, but I'm not going to this time. So on the left-hand side, I have 1 plus sine squared over cos squared. And I have this 1 here. Well, this 1 has a denominator of 1. So I need to times the top and bottom by cos squared. So I could show that step, or I could just do it. 1 over 1 is cos squared x over cos squared x, right? I could write it up to the left, like right here, and then write this exact same answer down below, or just write the answer. So why not? Plus sine squared x over cos squared x. And anyone who wants to try the old method, if we have the same denominator, we can extend the fraction below the sign to the other side and cross off one of the denominators and answer the question, but I'm going to show a couple more steps. So we have a lowest common denominator of cos squared. Often I'm going to start off with the fraction, and I'm going to put cos squared on the bottom. Why not get a thought out of the way? It will help you work on the top. Getting it out of the way, not having to know, oh, I got to work on the bottom in the future. It's out of the way. Now we have cos squared plus sine squared. I'm going to write it sine squared x plus cos squared x. Anyone have a problem with that? I hope not. Now I'm going to look at the top. Well, I see that sine squared plus cos squared is on the top. I'm going to circle that in red. Sine squared plus cos squared. And I know sine squared plus cos squared from my Pythagorean identity in the top left-hand corner of my formula sheet, which we should have out right now and pointing to. Sine squared plus cos squared is 1. So I can replace sine squared plus cos squared on the top with 1. The denominator is still the same. Now, I could waste another line and write secant squared x below it because I know the definition of secant is 1 over cos. But I'm going to work on the right-hand side and say 1 over cos squared x. And then I'm going to say check mark or QED, or whichever background you're from. And I'm going to circle both my answers on both sides. 1 over cos x is equal to, 1 over cos squared x is equal to 1 over cos squared x. Check mark QED. So there's a bunch more questions on that page that change from different identities and add and subtract fractions and use the Pythagorean identities, and then a little bit more complex fractions down at the bottom there. But we've already gone through the basics in earlier parts of the chapter on the simplicities of the different ratios and how to work with them with adding and subtracting fractions. So I encourage you to look through the notes and try and follow it yourself. Ask yourself, what just happened? How did that change to that? What happened to make that flip there? Well, I've seen that before. Dividing. Oh yeah, grade 8. Dividing, flip and multiply. Because a lot of the times the teachers in the future are going to start being lazy and show less steps, as I've shown you in the past here. And you want to be able to follow when they do those different lazy steps, or else you're going to be behind if you're already always writing down the definition and doing the algebra and then the substitution, or the adding and subtracting fractions with the lowest common denominator. So again, take a look through those notes and make sure that you can follow them. I've used a couple of colors to help out, but really try and go, yep, they added fractions, or yep, they found a lowest common denominator, or they used that identity. I've seen that before. And always checking my work, because sometimes it's incorrect. Okay, on to the conjugate. This one is interesting.